All right, welcome back. This course description is going to be about Introduction to Computer Vision, and it's a course that's provided at Stony Brook for the graduate school, and I think they have an undergraduate as well. The idea for this particular video is to break down all the classes that are given as a part of the graduate school program, and also to find some insight into whether or not I want to just get my master's degree or get more than that. So the idea is to listen to all these courses that are available, find out information on the internet, and then to come up with some sort of like strategy to be successful in this particular program. So let's get right to it. So to this Introduction to Computer Vision, it's CSE 527. It's a part of the Information and Intelligent Systems topics. And the course outline basically says Introduction to Basic Concepts in Computer Vision, low-level image analysis, image formation, edge detection, segmentation, image transformation for image synthesis, methods for 3D scene reconstruction, motion analysis, and object recognition. So that's basically it. It was all for that particular course. Since I didn't have a decent enough information about computer vision when I first looked at it on the site, I decided to go ahead and check out Wikipedia because that's the next best thing for me. So computer vision is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. From the perspective of computer engineering, it seeks to understand the automated tasks that the human visual system can do. Computer vision's tasks include methods of acquiring, processing, analyzing, and understanding digital images and extraction of high-dimensional data from the real world in order to produce numerical and symbolic information. Examples are in the form of decisions. Understanding in the context means the transformation of visual images, the input of the retina, into descriptions of the world that make sense to those processes and they elicit appropriate action. This image understands can be as the disentangling of the symbolic information from image data using models constructed with the aid of geometry, physics, statistics, and learning theory. The scientific discipline of computer vision is concerned with the theory behind artificial intelligence, extract information from images. The image data can take many forms, such as video sequences, views from multiple cameras, multi-dimensional data from a 3D scanner or a medical scanning device. The technological discipline of computer vision seeks to apply its theories and models to the construction of computer vision systems. Subdomains of the computer vision include scene reconstruction, event detection, video tracking, object recognition, 3D pose estimation, learning indexing, motion estimation, visual servicing, 3D scene modeling, and image restoration. And it goes on into, the definition of what computer vision is, which I just spoke about before at the top, and then it goes over into its history and its related fields. So getting after basically understanding this is really interesting because it kind of talks about how we can utilize the human eye or the human vision, as the foundation for trying to, understand how computers can understand and focus on things very similar to how a human can do it. And it's really interesting because of the fact that a lot of things in our technology is taken through that. For example, like the camera. The camera lens is based off of the human eye, so it's not really interesting. It's not really surprising that we don't use this. And it looks like this entire time in our society of computer science and computer engineering has always been this future goal to kind of create this other being. I don't know if that sounds really weird. It's basically to create artificial intelligence in some shape or form. I believe that a lot of this stuff takes a lot of time and resources and understanding, so we need to pay a lot of attention to what these courses are basically going to give us when we learn them. So for right now, I don't know about any particular projects offhand that provides any particular understanding, but like what I would usually do is try to check out some open source libraries, and one of the open source libraries I look at is OpenCV, which is basically is an open source computer vision library, and it's a library of programming functions aimed to aim at real-time computer vision. It was originally developed by Intel. It was later supported by Willow Garage, then ITSEs, which is later acquired by Intel. So I don't know if this particular repository is still being managed, but it's written in C++. The idea behind this particular the idea behind this is that it actually has courses that allows you to learn a little bit more about it. And it has, so what the course is called opencv.org/courses, and it's called Real World Applications Computer Vision 1 and Introduction and Basics Computer Vision 1. And Computer Vision 2 is Real World Applications, and then Computer Vision 3 is Introduction to Deep Learning with Python, it said? Oh, with PyTorch. And the courses are a little overbooked. So they pretty much have, so this is really a popular, project right now, being able to do these things. And I'm actually a little bit more excited than I was when I first read this, actually looking at this right now, because of the fact that there's just so much going on inside our society today about technology, computer technology, and computer vision is probably something you would want to be able to do. If you can get a computer to able to understand what it's looking at, then you can do a lot of things. You know, like one of the things I'm actually thinking about being able to do is that you can give it pictures, and then it could detect what the pictures are, and then could keep a log of all the things that is in the room. So like for instance, right now you're looking at this picture, this video. It can watch the video and then can see that, oh, there's a guitar there. There's a man who looks like he is a particular age or a different ethnicity. You can see that he's probably sitting in a room and he's not sitting outside. You can see that there's other things behind him, and be able to do that is great. That's like amazing. If you could do that, then you can use code to do other things, So the whole idea is to try to combine all these things. And I'm really excited about this class. I probably will try to see if there's any courses anywhere else. Let me just write down opencv.org. So to find out about it, I'm pretty sure it's going to be booked right now. Like this, like it's something like right now. It's really popular right now to kind of do a lot of these things, but the idea is to really get into all these things. Well, not everything, but to figure out where I want to go with my mind and trying to focus on it. And I have this is a great one. The State University of New York actually has a computer vision's basics course that probably talks about you understand what computer vision is and its goals, understand the digital imaging process, and identify some of the key application areas of computer vision. And you apply mathematical techniques to complete computer vision tasks. And it looks like it says that it takes approximately 10 hours to complete. And the course is actually all in English. So that's great. I'm pretty sure, what type of project would you're going to use MATLAB to kind of focus on these things. So you have to learn some new technologies. And there is a free license that's also available to install MATLAB for the duration of the course, thanks to MathWorks. So I'm definitely going to look into that. That's great. And I'm actually over right now in this video. So next video is going to be computer graphics, in which I'll be discussing all the things that are in that particular course. And when I get back, we will continue there. All right, take care.